dspy's declarative programming model leverages signature-based abstractions to encapsulate input-output behavior, enabling modular interaction with language models through structured field specifications. This paradigm allows developers to define task requirements semantically while abstracting prompt engineering complexities. We will examine how conversation history is managed through the dspy.History utility, demonstrating its integration with signature fields and runtime message tracking. The implementation will showcase the initialization of a question-answering signature, the iterative processing of user inputs, and the persistent maintenance of conversational context across interaction turns.
Import dspy. Import OS environ OpenAI API key equals your OpenAI API key. dspy configure elm equals dspy lm OpenAI /GPT-4o mini. Class QidSpy signature. Question SDR equals dspy input field. History dspy history equals dspy input field. Answer SDR equals dspy output field. Predict equals dspy predict QA. History equals dspy history messages equals. While true. Question equals input type your question. End conversation by typing finish. If question equals finish. Break. Outputs equals predict question equals question. History equals history. Print feed / outputs answer /n. History messages append question. Question * outputs. dspy inspect history.
This code demonstrates a foundational pattern for building conversational QA systems with dspy, focusing on stateful interaction management. The core architecture uses a dspy signature to declaratively define the QA behavior with 3 fields: question, history, and answer. This signature-based approach separates the task specification from implementation, allowing dspy's optimizers to handle prompt construction. The implementation leverages dspy.Predict as the fundamental module, which abstracts the prompting mechanism while remaining signature agnostic. Conversation state is maintained through dspy.History, which stores message turns as dictionaries containing both input and output fields. Each interaction cycle follows a predictable pattern: user input collection, prediction generation, and history update via history messages append. This explicit state management enables context-aware responses across multiple turns. The design choice to use dspy.History rather than automatic state management provides flexibility but requires manual maintenance. The trade-off becomes apparent in production scenarios where conversation context grows. While the pattern scales linearly, developers must handle history pruning or summarization manually. The final dspy.Inspect history call reveals how dspy formats multi-turn conversations as alternating user assistant messages, maintaining compatibility with standard chat formats while preserving the structured signature approach. Let's break it down.
Import dspy.
Imports the dspy framework, providing access to its core functionality for working with language models through declarative signatures and modules.
Import OS.
Imports the standard library, OS, module for operating system-dependent functionality like file path manipulation and environment variable access.
OS environ OpenAI API key equals your OpenAI API key.
Sets the OpenAI API key in the environment variables using the value provided as a placeholder string. This allows the application to authenticate with OpenAI's API services when making requests.
dspy configure elm equals dspy lm OpenAI /GPT-4o mini.
Configures dspy to use OpenAI's GPT-4o mini model as the default language model for all subsequent operations. This sets the global LM provider that will be used by any dspy modules unless explicitly overridden in a specific context.
Class QADSPY signature
Defines a class QA that inherits from dspy, signature, establishing a declarative specification for a dspy module's input-output behavior. This creates a signature template for question-answering tasks, where the class name QA indicates the semantic role of the module, the inheritance from dspy. Signature means this class will be used to declare and initialize the behavior of a dspy module focused on QA tasks, with field names that matter semantically, e.g., distinguishing between questions and answers.
Question SDR equals dspy input field
Creates an input field named question with string type annotation using dspy's input field class. This defines a signature field that will accept string inputs, typically used to specify the expected input format for a dspy module or signature. The field name, question, serves as a semantic identifier for the input role in the task specification.
History dspy history equals dspy input field
Creates an input field named history of type dspy, history for storing conversation history in a dspy signature. This field will contain a list of message dictionaries tracking interaction metadata like inputs, outputs, and token usage.
Answer SDR equals dspy output field
Declares an output field named answer with string type annotation using dspy's output field class. This creates a typed field that will hold the output value of a dspy module, where the field name answer semantically describes its role in the signature. The type hint SDR indicates this field expects string values, while dspy output field initializes it as a dspy output field that can be optimized during compilation.
Predict equals dspy predict QA
Creates a dspy predict module instance named predict configured with a QA question answering signature. This sets up a basic building block for LM-based question answering tasks, where the module will process input questions and generate answers according to the specified signature behavior. The predict variable now holds this configured module ready for invocation.
History equals dspy history messages equals
Creates a dspy history instance named history initialized with an empty list of messages. This object will track conversation history, storing inputs, outputs, and metadata for LM interactions.
While true, question equals input type your question. End conversation by typing finish.
Starts an infinite loop that continuously prompts the user to input a question. The loop will only exit when the user types finish. Each iteration captures the user's input and stores it in the variable question.
If question equals finish. Break.
Checks if the variable question equals the string finish and exits the current loop if true.
Outputs equals predict question equals question. History equals history.
Calls the predict function with two arguments, question and history. This invokes a dspy module to generate outputs based on the provided question and conversation history, where history contains prior interactions for context-aware processing. The result is stored in the outputs variable.
Print feed \n outputs, answer \n.
Prints the value of outputs answer with a new line before and after it. This is a simple formatted string output that displays the answer field from the outputs object, surrounded by blank lines for visual separation in the console.
History, messages append question. Question * outputs.
appends a new conversation turn to the history's messages list, combining the question with all output fields from the current interaction. The dictionary unpacking outputs merges all output key-value pairs into the new message entry alongside the question field. This maintains a complete record of each interaction turn in the conversation history.
dspy, inspect history.
Calls the inspect history method from the dspy framework to display the interaction history of the current language model, including inputs, outputs, token usage, and metadata. This provides visibility into the LM's recent operations and resource consumption. This implementation showcases dspy's declarative approach to conversational QA systems through signature-based abstraction. The QA signature cleanly separates task specification from implementation, using semantic field names like question, history, and answer to define the expected behavior. The dspy predict module then operationalizes this signature, handling the actual LM interaction while maintaining separation of concerns. The conversation flow demonstrates explicit state management through dspy history, where each interaction turn is manually appended to maintain context. This design choice provides flexibility, but requires developers to handle history maintenance, including potential pruning for long conversations. The pattern scales linearly, but puts the burden of context management on the developer rather than the framework. The final, dspy, inspect history, call reveals how dspy formats multi-turn conversations, maintaining compatibility with standard chat formats while preserving the structured signature approach. This implementation effectively balances declarative task specification with manual state management, showcasing dspy's core philosophy of separating what needs to be done from how it's accomplished.
The history appends what the predict forgets. Yet the predict answers what the history never asked.